Okay. So let's keep going on the sum notation. All right. Another word about the indices, index numbers. Usually, let's just write up a sort of a generic one. Okay. So notice that we have the letter I here. This is the index. We usually use either I, J, or K, pretty much exclusively those three. That can show up, those can show up in the actual thing that you are summing up. That's very common. And then A and B are constants. B is usually, it is not always a number. It can be a letter, but it's a constant letter. Has to be. And A is less than or equal to B because I is increasing by 1 each time. Okay, this is how you keep track of it. It's always increasing by 1. You don't go from, say, 5 down to 7. I mean, oh my goodness, 5 down to 1 or anything like that. You would go from 1 up to 5. And if you have to do some backwards things, you would just do something like, I don't know, 1 minus I would give you, or you know, like 7 minus I, if you go from 1 to 5, would give you 6, 5, 4, 3, etc. I mean, you can count down all kinds of creative ways. But I always is going up, and so A is always less than or equal to B. If they're the same, I mean, if you just have, you know, from 1 to 1 of, I don't know, 7, well, you start at 1, so here's your first number, and you end at 1, so that's it. That's what you have. So it's very, very boring sum because it's only the one number, which is why it's not that big of a deal. You can have that. It's very boring, but you always have the lower number is smaller than the upper number. All right. What about something like this? You get, like I said, the index involved in the actual thing. What is going on here? Well, this is where you actually have to keep track of I sometimes. So I starts at 1, so you're taking the sum of I is 1 in this case. And then it goes to 2, so you're adding 2 the next time. And it goes to 3, so you're adding 3 the next time, and so on. 4 and add 5. What is this? Let's actually go to 6. I want to go to 6. All right, so what is this? Well, this 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, and then 5 plus 6 is 11, so this is 21. Now that is actually it's a little tricky. It's hard to get. There's some weird things going on, but you notice we started with 1. So at the very beginning, I is 1. And at the very end, I is 6. This is the stopping number, 6 right here. So, so what do we do with that? Well, let's do another example really quickly, just to see something here. Let's find out another property here. Let's do from 1 to 6 again, but let's do I minus 1.5. All right, let's do that. Okay, so we start with I being 1, we subtract 1.5, we get negative 0.5 as our first number. We have I being 2 and subtract 1.5 and we get 0.5. And then we have 3 and that's 1.5. But I'm getting ahead of myself. Let's actually write out each individual parentheses as it shows up. That might make things a little clearer. This is one of the actual benefits of using the notation is you don't actually have to hit a lot of buttons on your calculator each time because it does it for you often. Okay, so here are the same ones. Okay, so 1, 2, 3, 4, 5, 6. Okay, and we subtract 1.5, subtract 1.5, subtract 1.5. All right, what do you notice about this? Well, do you notice that we have, remember, we can rearrange these things as long as we keep the negatives with their appropriate thing and the positives with their appropriate thing, we can rearrange this however we want. So notice what we can do is we can take the first number of each one and put all those together. And what does that give us? Well, it gives us exactly this one, right? So we have the sum from 1 to 6 of just I. That's just taking the first one of each thing. Okay? And then we can add to that, or let's even say minus. From that we subtract. What are we doing each time? We're subtracting the sum from I equals 1 to 6. We're subtracting 1.5. That's what's happening each time. Okay. Got a little neater. All right, so what did we do? Let's look back at this. What is going on here? Well, because we can rearrange everything, if we have two things added or subtracted in here, it doesn't matter what they are, we can split those up into their own individual sums. And now we can see that this from here is 21. And what would this be? Well, we know that that's 6 times 1.5. So write that down. 6 times 1.5. 1.5 times 6 is 9. So 21 minus 9 would give us 12. Now, that was actually a lot easier than doing each individual one by hand. Now, we did actually have to do this part by hand. But there is a shortcut for that as well. The important thing I want you to notice, though, is that you can go from, now it can be plus or minus, and it doesn't matter what the two things are. In this case, it was minus, and so that got us a 12, but we could just as easily just change this to a plus, and that would give us this plus that, which would give us 21 plus 9, in other words, 30. And we can do that without adding a single thing, just properties of summation notation. So this is a very useful tool. All right, let's move on to another example of something really fun. I do want you guys to have this written down, but let's move on to another fun thing. So we get something like, this will be quite important later. We get something like, I'll use J this time. J equals 3 to 7, lots of 7s. Of let's say J squared. And let's just write this out, what this means, not actually add them together. Well, I mean, I have a calculator, so I can do this. But let's just write it out first. So we first have what is j? J is 3, so we have 3 squared plus then 4 squared plus 5 squared plus 6 squared plus 7 squared. Now, that would give us that is equal to 9 plus 16 plus 25 plus 36 plus 49. Now, I think what that's going to give us, I mean, that isn't too bad even for a calculator. You can type that in. That gives us 135. Now, notice which 2 squares we didn't have. Normally we start at 1. We were missing 1 squared and 2 squared. Those were not there. So let's think about another way we could write this. And this will be important in a second when we get to actually calculating a lot of these. What is missing can be just as important as what you have. What we can do is we can rewrite this something like this as, of j squared, and it could be really anything. The important thing is a trick with the index numbers. We can write this as the sum from j equals 1 to 7 of j squared minus, what were the 2 things we didn't have? 1 and 2. How do we represent that? J equals 1 to 2. Notice that this 2, this starts at 3, so we want to eliminate the one just before that. So if we drop off the 1 and the 2, this stops at 2, then we'll be left with 3, 4, 5, 6, 7. Okay, so keep this in mind, write this down in your notes. This idea is important because of a lot of things that we're doing. Why we are doing the summation notation in the first place. It's important to be able to think like this. But yes, let us first do some calculation in the next video.